Hi, I'm Kathy Levinger. In this lesson we're going to solve quadratic equations using graphing in the square root method. Let's start with an example. What we want to do is solve the following quadratic equation by graphing and then round our answer to 2 decimal places. What we see is negative 4x squared plus 5x equals negative 9. To solve a quadratic equation by graphing, it's to your advantage to get 0 on one side or the other. By graphing, it's not going to matter which side you move everything to. So I'm going to add 9 to both sides and write the quadratic equation as negative 4x squared plus 5x plus 9 equals 0. Now I'm going to pick up my calculator and graph what I see on the left-hand side. So on my calculator, I'll enter negative, well, not there, actually, in the graphing area, negative 4x squared plus 5x plus 9. Now, I need to graph and solve this. Let me look at a graph on the window that I have. I'll show you the window, which is a standard window. Let me go ahead and graph and see what the graph looks like. If I need to adjust a window at this point, I will. This window is sufficient. The solutions to the equation are the points where the thing that I graphed, the parabola, is 0, which means is on the x-axis. So one solution is here to the left and one solution is to the right. Let's start by finding the solution, or the 0, on the left. We're going to use an option called second calc. Remember that calc is behind the trace button on your keypad. So choose calc and option 2, which is called 0. This will find an x-intercept, but what we need to do is move the cursor to the left of that 0 and enter, move the cursor to the right of that 0 and enter, and then use the calculator's guess or adjust the cursor a little bit closer to the 0 with an arrow key. And the calculator tells us that that 0 is the number negative 1. Well, let's find our other 0 by choosing second calc, option 2, moving to the left of that 0, but closer to it. Now I can see my cursor. My cursor is here. I'm going to enter on the left-hand side, enter on the right-hand side of the 0. And remember, what your calculator does is show you some boundary points on the screen. Enter and use the calculator's guess, and I see that that 0 is 2.25. So negative 1 and 2.25 are the zeros of this quadratic function, and therefore the solutions to the equation. Let's write them down. The solutions are x equal negative 1, x equal 2.25. And they're both already rounded to 2 decimal places. Let's try another of the same type of problem. We want to solve this quadratic equation by graphing, and we want to round our answers to 2 decimal places. As we started the other one, we want to get 0 on one side or the other of the equation. I'm going to add 10x and add 1, and I'm going to work on 25x squared plus 10x plus 1 equals 0. Work on solving that. So I'm going to go to my calculator, and in y equals, I'll enter 25x squared plus 10x plus 1. And let's check out the window. We still have a standard window. Let's push graph and see how this graph looks on that window. And we can always adjust it accordingly. Here's the graph. Let me look at y equals one more time. 25x squared plus 10x plus 1. What we need to do is zoom in or change our window to get a little better picture of what's happening here. Let me choose zoom 2. The cursor's right at the origin. I'm going to enter and get the calculator to redraw with a much smaller window zoomed in around the origin. It looks to me like there is a single 0, maybe 2. I could zoom in further to investigate. Right here on the x-axis or the horizontal axis. Let's run our second calc 0 option. I'll want to move the cursor to the left of what I think is a 0 and then to the right, and then enter and use the calculator's guess. And it tells me that the 0 is, for all practical purposes, x equal negative 0.20000. There are no other zeros. This happens to be a quadratic equation that has exactly one solution. So let's write that answer down. The solution to the equation is x equal negative 0.2. Well, we can also solve some quadratic equations using a method called the square root method. Not every quadratic equation is possible to be solved by the square root method. To use the square root method, we need an equation of the form something squared equals a number. And when the quadratic equation is in that form, what we do is take the square root of both sides of the equation using plus or minus in front of, in this case, the right-hand side, because there are two numbers that when you square them will give you 11, both positive and negative, the square root of 11. What happens on the left is the square root and square undo each other, and we see that the solutions are positive and negative the square root of 11. To write our answer to 2 decimal places on a calculator, we'll need to find the square root of 11, which is 3.3166 and so forth. To 2 decimal places, that's 3.32, and so we'll write t is equal to positive and negative 3.32, and perhaps I should write approximately since that is rounded. Let's solve another equation by the square root method. We want to solve 9 minus 9x squared by the square root method. We need to manipulate the equation and get the squared term by itself before we take the square root of each side. I'm going to add 9x squared to each side of the equation. Then I'll divide by 9, and I'll get 1 equals x squared. Once the squared term has been isolated, I can take the square root of both sides of the equation, making sure to write plus or minus in front of the square root of 1, since there are two numbers that when squared will give me 1, both positive and negative, the square root of 1, which simplifies to 1. And so those are the two solutions, both positive 1 and negative 1, to the original equation by the square root method. Let's try one more. Let's solve this quadratic equation by the square root method, and if necessary, we'll round. In this equation, we need to isolate x squared on one side, but that's also going to require combining some like terms. Let's start by distributing on the left to get 4x squared minus 8 equals x squared plus 10. And then I'll subtract x squared from each side to get 3x squared minus 8 equals 10. Then add 8 to get 3x squared is 18. And divide by 3 to get x squared is 6. I isolated x squared, so now I'm ready to take the square root of each side of the equation. Don't forget to write plus or minus in front of the square root of 6. The square root undoes the square, so I get x on the left equals plus or minus square root 6. Let's get a decimal to 2 decimal places for the square root of 6. Square root of 6 is 2.4494 and so forth. We'll round that to 2.45 and say that x is approximately positive and negative 2.45. Let's look at an application problem that might require one of these two methods to solve. The problem says, if a coin is dropped from the top of a 65-foot building, how long will it take to reach the ground? Well, there's a formula that we're going to want to substitute into to come up with an equation. The formula you'll see in your book is h of t equals negative 16t squared plus h of 0, or the h's could be s's. H sub 0 is the height from which the object is dropped, in our case 65. T in this formula, this is a vertical motion model, always represents time in seconds, and h of t is the height of the object in feet as a function of time, or for each of the times that are represented by the formula. For our particular problem, since the object's dropped from the top of a 65-foot building, we have this model. The first is the most general vertical motion model for an object that's dropped. We want to know how long, or what's the time that it will take till the object reaches the ground. When it reaches the ground, its height is 0, and so we want to solve for t in this equation. This is an ideal equation for which to use the square root method. I'll start by adding 16t squared to each side. Then I'll divide by 16 to get t squared is 65/16. I take the square root of each side of the equation using plus or minus. However, I can see that the square root and the square simplify, and I recall that t is time. Time is not negative, so I don't need to keep the negative square root of 65/16, only the positive square root of 65/16. And let's find that time on a calculator. On a calculator, we'll find the square root of parentheses 65 divided by 16, and that's 2.015 and so forth. Let's say that's approximately 2 seconds. So from a 65-foot building, the coin will take 2 seconds to reach the ground. Let's try one more application. If $3,000 is invested for 2 years in an account that has interest compounded annually, yearly, what was the annual interest rate if at the end of 2 years the account contained $3,466.87? This problem also requires that you use and know a formula. The formula is A equals P times 1 plus R squared. It's the amount of money you have if a certain principal, in our case $3,000, is invested at an interest rate of R compounded annually for 2 years. So this formula actually only works for annually compounded interest for 2 years. But it'll work for our problem. What we'll do is put 3,466.87 for the amount of money we have, because we know that number. We know we invested $3,000. We want to know R, so we don't know it, and there's a square there. Well, this is definitely a square root method problem. The first step is to isolate this squared part by dividing by 3,000. Well, let's take a minute and actually do that division on a calculator. We want to take $3,466.87 divided by $3,000, and that comes out to 1.15562. We rounded at that point, but we did keep a number of decimal places, and that'll be equal to 1 plus R squared. So we've isolated the squared term. Now we're ready to take the square root of both sides of the equation using plus or minus in front of the side that only contains a number. On the left-hand side, the square root undoes the square. On the right-hand side, I'm going to grab a calculator and figure out what the square root of that number is. Now that number happens to be on my keypad. To keep more decimal places, what I can do is find the square root of my answer by pushing second and the negative button, which has the letters A and S behind it. Close parentheses. That square root is 1.07499, so we could round to 1.075 and write that down. We don't need to keep the negative version of that because we're talking about interest rates, which are positive. And I'd like to solve for R, so I subtract 1 and make that a percent. The money must have been invested at 7.5% interest. Well, in this lesson we've looked at solving quadratic equations using graphing and the square root method. Be sure to work lots of exercises from your textbook to practice.